structures. Why does growth occur at the extremities of the tree? Why is there not more growth down the center? Well, if we look at this tree as a system of energy pathways in all the little tubules and sap ducts and so on, when you get to the top of the tree, then these are all very close together, which means that they're minute in size, and in a sense also there has been a tremendous increase in the potential, in the life energy of the tree at that point, so that what is passing up these very small sap ducts are only the very finest materials, the sort of homeopathic substances, which, because they have been potentiated, create the greatest energies for the tree to grow, whereas down here at the bottom this doesn't occur in the same measure. Very important too in our understanding of the interaction of trees is also the root structures, because we can create an enormous amount of harm by pulling out a species of tree which may have a certain root structure which helps the whole balance of the forest. And although these aren't trees, I'm going to put these on one after the other in order. Here you would see a very simple plant which perhaps was the original plant which grew in this place, maybe a sort of primordial plant. In the process of growing, it made a little bit of shade on the surface. It created coolness below the surface. It trapped a few particles from the wind, and that allowed another plant to develop. But this other plant had roots which came in a different area. They didn't actually compete so much with this one. It had a different root shape, and it was more broad spread, and it again created more cooling. That means that the depth of moisture would increase. More particles were trapped by the wind, which then would allow another plant to come and take root, which had a deeper root system. And that in turn multiplies more complexity, better ground cover, and another plant with a different root system would come in, would grow, and this would give way to the possibility of yet another one to come, and so on. So all these plants gradually, these are all real plants, mind you. These are not just drawings. There's someone actually measured all these. They're actual plants. So by the time you get, you get a significant complexity of roots. But if this one, the last one I put on, was the major one, which was the major species, which happened to be very good for making furniture with, so everybody took it out. Then when I take it away, suddenly, where's the water going to come from? Because this plant was actually going down and getting the water and bringing nutrients up for the other plants. So it's very important that always there's as many varieties of plants and trees as you can have in a normal forest. These are more or less the same roots that I showed you before, but that is their relative distances. This is 4 meters below the surface, and the other ones are there. These are actual plants, and it shows what and this is only a few, because the book that I have has got about 260 different root systems like this. So when you understand this complexity, this huge Gordian knot which is occurring underneath the ground, then it begins, you understand why it is so important to have all the diversity, because it's the diversity which allows all the plants to take from different areas, to take minerals, and they don't compete with each other as they would in a monoculture situation. Okay, now we're going to dip lightly into the mathematics of all this, which have largely been determined and formulated by Walter Schauberger. Walter Schauberger was a physicist and a mathematician, and when his father died, he agreed, or he promised his father, that he would try and develop a system of physics and mathematics which would explain Viktor's theories in a way which was irrefutable, so that it could never again be said that Viktor Schauberger's machines didn't work or that his theories were invalid. And it was this task which Walter set himself upon the death of his father in 1958, at the time when they came back from the United States. Walter Schauberger's mathematical system is based on the harmonics of the monochord. This is an instrument which was used by the Pythagoreans in order to determine harmonic intervals on a resonating string. And these intervals can only be determined or only positioned at whole number divisions of the string, so that if you divide an open string 1 into a half, then you get the first octave. So just to the right and the left of this point, half position, you will not get a state of resonance. It only comes when you have done it exactly on the point divided by, where you've divided the string by 2. The same occurs when you divide it exactly on the point dividing the string by 3, in which case you get a sort of tripartite waveform which moves between the nodes of where the string is divided. When you divide it by 4, then of course you get the second octave. And so that any string of whatever kind would produce at once a series of overtones, which are the overtone series which rises from above them, and also in the same sense a series of undertones. And Pythagoras and the Pythagoreans made a study of these because it was important to determine the harmonics of things, because they saw the world as being the manifestation of qualities and harmonics or harmonies. And in fact, the student had to study or pluck upon a monochord for maybe a year or 2 years until he could hear 120 harmonics on the string. Now that means the harmonics will get to an extremely high level. This was then important in order to realize how, just before I continue that, actually, just to show you how this links up with the hyperbole we saw before. If I can put that to the side and put this on here, then you will remember. Then you can see that the full length of the string is 1, which is from here to here. The half is there, and the third is there, and the fourth is there. So that in fact this whole hyperbola, it represents the division of a string into an infinite number of integral divisions, i.e. dividing by a whole number. And as it's infinite, so at the top of it, the quality, in the sense of quantity times quality, the quality is infinitely high, as is the vibration at the top. And this gives us some idea of how higher qualities and higher energies and higher vibrations become the controlling force, because if we take, for instance, these vibrations at the bottom, we'll say they're 1, 2, 3 cycles per second, or 2, 3, 4, 6 cycles per second. In order to be able to resonate with more and more, and to be in harmony with more and more things, we have to raise our vibration so that what is the next higher vibration is in tune with all of these. So if we take the next higher vibration, for instance, as being these green ones, then the vibration of 30 cycles per second is directly harmonic with 2, 3, 5, 6, 10 and 15, all of which numbers will divide equally into 30. Or 12 would be 2, 3, 4 and 6, or 10 would be 2, 4, 40 would be 2, 4, 5, 8 and 10 and 20. But again, once again, these, in order to combine them into a harmonic whole, they need to be again associated to a higher number even than themselves. So a number 120 would be the number in which to all these various numbers 1, 6, 10, 12, 15, 20, 13, 40 are all can all divide into equally. So that we come back to what I said earlier on about energy, about the higher energies being the formative energies. And when we look at this vibrating plate, we can see again how vibration creates a particular form. Here is a square plate with sand just sprinkled over it. The vibration is started and gradually the final form arises. And when that vibration is doubled, or when the next octave happens, then, as is shown in here, which is a different pattern, then the pattern becomes more complex. So here we have the first, what you might call the bass tone. There is the first octave, there is the second octave, and there is the fourth octave. Again, the complexity increases